Hello, welcome to this video on Rigidbody.AddForce. So in this video, we're going to take a break from the user interface and scene management stuff we've been looking at lately, and let's get back to adding some new functionality in this game. So we're going to add a jumping behavior. We'll see how we can turn on gravity and what rigid body constraints are and why they're useful. We will actually call the Rigidbody.AddForce method, and we'll see how that works. And we'll talk about this force mode .force versus .impulse, which is actually an enum. So we'll see how this works. So let's start by looking at the player's rigid body. I'm going to go to player here, scroll down to rigid body. Maybe I'll move this component up with the collider. Okay, so here's the rigid body. And we'll see there's actually this use gravity option. And gravity is important when you're jumping. Let's actually add the jumping in without gravity. Then we'll come back and we'll check use gravity. So as you can imagine, I'm going to make a new jumping script. I'm going to put this on the player, on the logic side of things, just because that's going to be controlling the physics. So create a new C# script. I'm going to call it jump. And we'll open it up. And when it reloads, we will also attach it to the player. Okay, attach jump to the player. So there's our jump script on the player. Very nice. Move it down there again, actually. Okay, jump script is there. And let's see what we want to do. Okay, so our jump script is going to need to know when the user wants to jump. That's part of this jumping behavior. And then we'll also need to respond to the jump input with an actual jump. So if we go to the movement script on the player, we'll see something similar to this. See, we already have in movement this update function where we say if we are pressing the A key or the left arrow key, then I want to do something to the transform. That's transform.position. And in this case, we're going to do something similar. So let's go with update. But here we're going to say if input.getKey keycode.space. I'll do the space key. You can do a different key if you want. Then we'll want to jump. So let's say debug.log jump. And we'll just see if that's working how we want. So just start really basic for now. And let's see if we can get that jumping logic working. So test it out. Okay, we'll open our console. And even before the game starts, we can just press the space key. And notice there's already about, if I just stop it there, there's some 200 messages. And notice how many times jump is being presented here, is being printed. Why do you think that is? See if you can pause the video and figure that out. Okay, good job pausing the video and figuring it out. So yes, you're right. Get key is actually going to return true as long as the space key is held down. If we put get key down, save that and run that again, it's only going to debug.log when in the one frame when the space key gets pressed down for the first time. So I can mash the space key, but if I hold it, it's only going to print once on the moment that it was held down. So that's good. We fixed an early bug that could have come up. That's debug.log jump. And now we want to actually be able to make our player move upward when they jump. So to do this, we could, in theory, we could go get the transform and we could change the player's position. And you could do some physics calculations and figure out where the player needs to be at each moment in time over the course of the jump. I'm sure you could use a coroutine. It's not that complicated to do. But there is actually a physics system here. And rigid body is part of that physics system that makes this much easier than doing all those calculations. So we can go get access to this rigid body and just say we want to add a force to the rigid body, and we'll let the Unity physics engine do the calculations for us. So let's go get a reference to this player's rigid body. Now, because it's on the same game object as the jump script, we can actually just go directly and get a reference to it in Awake without needing to do any drag and drop or anything. So we'll need somewhere to store this reference. So RB is a common variable name for a rigid body. Maybe I'll just call it, I'll call it RB, that's fine. Okay, and then we'll go into awake, and we'll just say RB equals get component rigid body. So now we have a reference to our player's rigid body, and now if the space key is pressed down, then what I want to do is say RB dot, and now rigid body has a whole bunch of methods here that we can use, methods and fields and probably some properties. So if you look for add force, there's some different ones. There's add relative force, add explosion force. Interesting. So let's just use add force, and there's different ways to add a force here. What I would like to do is just write vector3 dot up. So that's going to be the direction of the force. It's upwards. And then we would like probably also to have some sort of multiplier on that, because vector3 dot up is a vector3 with a y of 1. And so maybe we want to jump a little higher than that or a little harder. So let's go serialize field, private float jump force. I'll put that above this private rigid body. We'll do up times, so this is a jump force, it's a float, so it's just going to scale this vector3. And because x and z are 0, x and z are still going to be 0, but y is going to get scaled by jump force. And let's just put it there for now, and we'll see what that looks like. So add force with this jump force. We'll make sure we set jump force in the inspector. Okay, so the jump script currently has a jump force of 0, so we'll just make sure we set maybe 10. We'll see what that looks like and press play. And we'll wait till the game to start, and we'll press spacebar. And I don't actually, oh, there it is. So I'm really mashing the spacebar. You can see my player is really moving up there. If I press F key there, my player is actually always increasing in the Y, you can see there. So my player is going upwards. But that wasn't actually a very strong jump. And of course, there's no gravity too. So let's leave gravity off for a second. But that wasn't a very strong jump. Now, there's actually different force modes you can choose to use here when you're adding a force. So that's the second argument in this function. You can put the force in and then the force mode. And that's an enum. So following up from our previous video, if I write capital F force mode, and then you'll notice Visual Studio is telling me here that's an enum. So it's specifying the way that we apply a force. So if I put force mode dot, there's 4 options. There's force, acceleration, impulse, and velocity change. So these all work just a little bit differently. But I'm going to choose impulse as a force that kind of hits and has a short time frame, but it pushes all the force into it in one go. So I'm going to put impulse there, and that's going to be more responsive when I press the space key. Now the regular one is force mode dot force. So that's the one that we use by default if you don't put anything there. But I'll put impulse, and we'll see what the effect of that is. Okay, so already seeing a use for enums, very exciting. Wait for the game to start, and we'll press the space key. And notice I actually had a lot of, well, I went up quite a bit when I pressed the space bar instead of going up just a little bit. So there we go. We have some sort of jump working, but obviously not working well. Let's go and enable gravity. So you can just go to rigid body and use gravity and press play again. And we can see as the game starts, we are falling through the floor. So that's interesting. What happened here? So this player currently is trigger checked. And what that means is that let's find the floor here in the scene. Okay, what that means is that basically if either one of the colliders that are interacting is a trigger, then they just pass through. And you've seen that, right, you've seen that with the coins. When we pass through the coins or pass through the obstacles, we just pass right through. Oops. Go here. Okay, so you just pass right through. And what we would like to do is actually have a physical collision. And so the floor is not a trigger. That's good. The player is also should also not be a trigger. So what if I uncheck is trigger there and press play again? Okay, we're not falling, but now I actually crash when I run into the obstacle, because the obstacle is also not a trigger. And so I have a physical collision between the player and the obstacle now. So maybe I should make all the obstacles triggers. I think that kind of makes a bit of sense. That's probably a good way to handle this. Okay, so instead of changing every obstacle individually, let's open up prefab mode for the obstacle. Go down to the collider and choose is trigger. Very good. We'll do the same thing for the coins. So I think we can do this on the coin prefab itself. Let's open up prefab mode for the coin, and that is a trigger already. Okay. So we can just open up the prefab variants here and make sure those are triggers. Looks like they are. So let's make sure that this is working okay for now. You can also try jumping just for fun too to make sure that works. So obstacles are still taking away points. Okay, our jump is pretty high now actually. And we're running into the floor. So more problems. And as soon as I start introducing physics and gravity, right, things start getting a little bit weird, because tiny little deviations in the player's position or in the player's in what forces are added to the player, they start to add up over time, and I end up kind of tilting over. So things are working pretty well right now, but one thing that I can do with the rigid body is add some constraints. And so the constraints on the rigid body are going to mostly prevent the player from either moving in different positions or from different positions or rotating. And so in this case, we want the player's position to move, so we won't freeze those ones, but we will freeze the rotations. And so I don't want the player, if I click on the actual player here, right, I don't want the player to be able to rotate like this. Right, that's along the y-axis. You notice as the green arc I'm moving here. So I don't want that. That's the y-axis. So I want to freeze the rotation on the y. I also don't want the player to be able to, maybe I'll just grab the model just for demonstration purposes. I don't want the player to be able to actually tilt forward like that either while running. And I also don't want the player to be able to rotate side to side. So actually, all three of these rotations here, we want to constrain, and I say mostly constrain these positions. What I mentioned before was, and what I mentioned before about these positions and rotations mostly being constrained is that sometimes you can still get kind of some weird behavior with constraints where the player can still rotate a little bit or move a little bit. If it's constrained, and that's because we're changing the transform at the same time as we're applying physics, and so those two things can be at odds a little bit. But for this project, I think it's okay. We shouldn't have any issues freezing it here. So let's just decrease the jump force, maybe make it 2. We'll see what that looks like, and we'll see if these constraints are working properly. Okay. And now we go and press start. Okay, or press the space bar rather. It's a little bit of a lame jump, so I'll make it a bit of a higher jump. But for now, that looks okay. Okay, your challenge for this video is to just make the player jump on input. So follow the tutorial, make sure the player jumps, get a nice jump height that you are happy with. And once you have that working, we'll see you in the next video.